So today I'm gonna keep going on the C++ course. Hopefully I can do the whole thing. Well, not the whole course today, but the whole thing without paying for the extra stuff. So I'm gonna start the timer now. I'm gonna spend probably 2 hours here learning this. Nin 99 bottles. In the last exercise, we saw an example of an incrementing for loop. So here we are going to show you how to write a for loop where the counter goes down. We know exactly how many times we want to iterate or when we are counting. You can use a for loop instead of a while loop. So pretty similar to JavaScript. I think let's see if I already forgot the stuff that I learned from previous lessons. Write a 99 bottles CCP program that prints the verses of the 99 bottles song. Stanza goes something like this. Bottles of pop on the wall. Take one down and pass it around. -1 bottles of the pop on the wall. Use a decrementing for loop. So that should be -3. Mine's minus. 0, 1, 2. The first time. So I'm gonna make a condition that says, I don't remember now if I should put only if or if there's something more that I need to do. I equals 1. Standard count like this. Oh, there's actually I. Then, well, no, that's wrong. I equals 1 is the first. One down. That's it. Wrong. I imagine they only want me to write the first 3 lyrics, first 3 lines. Else I bottles of on the wall. And I forgot to put this thing here at the end of each thing. Oops. Run. So what's wrong here? So maybe the way that I'm doing if is wrong. What have I forgot? I can't remember. Expected this before token. So maybe it's here the problem. Oh, I put a comma here and it's not a comma. So maybe it's not the if statement. No, still giving me the else mistake. Oh, so maybe, yeah, it's because I put this here. So that means that the line ends there. If I put there the stuff. Oh, what's going on? Maybe I should refresh the page. Oh, didn't copy the for loop statement. A 0, 1, sure. Should do this, you just press Alt and then the arrow keys. Maybe the so, and this is just tab. Should go back, Shift tab. So int or int I equals 0. Oh, I forgot the I. See now, the else problem. Also forgot this. So what's, oh, I forgot the if here. Maybe that's the problem. Now it's losing connection again. So maybe it's just a way, maybe just the Code Academy backend that is not working. Let's see if I did it right. Oh, they wanted me to do for more than one line in 3 lines. If you notice the run button spinning continuously or lost connection to a Code Academy message in this exercise may have an infinite loop. If the stop condition for our loop is never met, oh, it's because I didn't put I++ at the end. Oh no, but should work because it's I minus minus. Oh, it'd be I++ and not I minus minus. I should initialize it to 3 and do the other way around. 3 minus minus. That's the problem. So maybe this passes. So it starts at 3. So if I equals 2, it starts at 2. Then, no, maybe 3, 2, 1. Then if I is greater than 0. No. So maybe this is an infinite loop again. Equals 3, I greater than 0, I minus minus. It should run 3 times. First time is 3. Second is 2, then is 1. So what's going on? You create an infinite loop which stops our program from running anything else. Checks it out of an infinite loop. In exercise, refresh the page, then fix the code for your loop. Your for loop should have a counter that starts at 99. So it should start to 99. They want me to do the whole lyrics, which means I shouldn't do this stuff. Maybe I'll copy this. Yeah. I don't know this song, so oh, no, 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 it's right. Now it's right, but maybe before it wasn't working because I didn't have the brackets for the int main. You also gotta remember to put these things at the end of the lines, which I always forget. Let's see if this runs. Nice. Oh, I need to pass new line as well, which I always forget as well. Because usually you don't have to on other languages. Next. Real great job, key concepts covered in this lesson. Loops perform repetitive actions so we don't have to code those actions manually every time. How to write while loops with a condition inside, with a continual condition inside. No, with a continual condition. How to write for loops with a counter that increments or decrements. So they didn't say. I guess I should just pass this one. Introduction to bugs. First actual case of bug being found. The story goes that on September 9th, 47, computer scientist Grace Hopper found a moth in the Harvard Mark II computer's logbook and reported the words first literal computer bug. However, the term bug, in the sense of technical error, dates back at least to 78 and with Thomas Edison. Your programming journey, you are destined to encounter innumerable red errors. Some even say that debugging is over 75% of the development time. But what makes a programmer successful isn't avoiding errors, it's knowing how to find a solution. There are many different ways of classifying errors, but they can be boiled down to 4 categories. Compile time errors, errors found by the compiler. Link time errors, errors found by the linker when it is trying to combine object files into an executable file. Runtime errors, errors found by checks in a running program. Logic errors, errors found by the programmer looking for the causes of erroneous results. In this mini lesson, we will be looking at different errors and different error messages. And we will teach you how to think about errors in your code a little differently. So there's compile, when the program is compiling, link time, and the linker is trying to combine object files into an executable program. I'm not very familiar with link time, the concept, and how it's different than compile time. Executable. So I guess it happens after the compile time, or maybe before. So compiling is when the code is being translated into machine code, so the machine can run the code. And link time is when the objects are being combined into an executable file, into an executable program. So when the files are being put together. So I think link time happens before compile time. The runtime errors and logic errors, errors found by the program looking for the causes of erroneous results. Okay. Compile time errors. When we're writing C++ programs, the compiler is our first line of defense against errors. There are two types of compile time errors: syntax errors, errors that occur when we violate the rules of C++ syntax; type errors, errors that occur when there are mismatch between the types we declared. Some common syntax errors are missing semicolon, missing closing parentheses, square brackets, or curly brace. Some common type errors are forgetting to declare. I need to remember the name of this because I always forget how to say it. Square bracket. Types error, forgetting to declare a variable, storing a value into the wrong type. Here's an example of compile time error message. The compiler will tell us where line number it got into trouble and its best guess as to what is wrong. Run this guy real quick. Try compiling the code and find the compile time error in millionaire.cpp. So at first glance, I can't. Maybe it's this one. Yeah, it's gonna be here. So it's not showing anything on the terminal. So it's not there. Let's see. All of the lines have this thing here. Maybe it's this line. It's broke down into 3. It's too long for B. Oh no, here there's 2 double lines. Maybe that's it. There's 2 double lines, new lines here as well. So I'm not sure if that's from C++ or not. The arrows seem to be correct. The square here is not declared. Oh no, it's declared up here. And answer is also declared here. The issue is not showing anything on the console. So maybe if I erase this stuff. So if it wasn't that, I think it might be put new line here. Yeah, but the problem is it's only a space that's separating them. So maybe the phrase is should be like that. It's not supposed to be in different lines. But if the line doesn't fit, then maybe it has to be. What else can be wrong here? Maybe this one has to be like this as well. Standard. Everything seems to be correct. I don't understand. Well, that is something that I don't really know about. There's a parenthesis here that is not closed. It's just a parenthesis, but it's inside of a string, so I don't think it should give an error message. Shouldn't be a mistake by the program compilation stuff. So maybe these lines have to be with this, but that doesn't make any sense because it's inside of a string. They all have standard quotes, correct? Yeah, I think it is correct. The arrows. This is also correct. Yeah, I'm not sure. I'm gonna look at this hint here. Oh, so I need to run on the thing here. Standard quote. So it is this stuff. Expected before standard. Oh, there's a missing here. How did I not see that? It's crazy. Let's see if it runs now. Nice. I looked at the whole code and couldn't see that. That's insane. Imagine when it's a very big code. It's gonna be a problem. Do you want to be game dev and chose C++? No, I'm just learning so I can build a library of artificial intelligence. My own library. Initially, I'm gonna try to use the TensorFlow lower level API to build it. And then maybe later, if I can build with the TensorFlow API, I'm gonna try to build it on my own completely. Because I wanna have more flexibility and yeah, I think C++ is better than Python because it's faster, but the reason people prefer Python is because there is more documentation and it's easier to learn. So they choose Python out of comfort. There's always a trade-off because uh, Python is simpler but is faster, so you don't lose a bunch of time. But I think learning C++ is better because it allows you to understand more about programming in the process while you also learn a new program language. So it's kind of like killing two birds with one stone, in my mind. But I'm not sure if that's a good idea because I'm not sure if when I start building the stuff it might be too hard because there's not enough information or libraries or documentation to build this stuff on my own using C++, and it's just a waste of time because I could be doing things much faster with Python instead. But the thing is, I don't want to be trapped by. I don't want to be stuck with the modules they have already, because I think it doesn't really allow you to really solve hard problems, because you're just taking a basic framework and applying it without really understanding. So I think in order to have something that I can really build some difficult problems with, I'll have to. I will need to have more flexibility and more understanding of neural networks, so I can play around with the concepts, the tensors and stuff, instead of just building layers with carrots and then yeah. Link time errors. Sometimes the code compiles fine, but there is still a message because the program needs some function or library that it can't find. This is known as link time error. As our program gets bigger, so let me read that again. Sometimes the code compiles fine, but there's still a message because the program needs some function or library that it can't find. This is known as a link time error. As our program gets bigger, it is a good practice to divide the program into separate files. After compiling them, the linker takes those separate object files and combines them into a single executable file. So yeah, this step comes before the compile, if I understand correctly. No, comes after the compile. And after compiling them, the linker takes those separate object files and combines them into a single executable file. So first there's the compiling, then the linker puts them together in machine code, I think. Link time errors are found by the linker when it is trying to combine object files into an executable file. Some common like link time errors: using a function that was never defined, or this later, writing main instead of main. So can already see here that's incorrect. Using a function that was never defined. Here's an example of a link time error message. So maybe this happens when you have multiple files and then the function was declared inside of the scope of one file and the other file can't reach, or something like that. Here's an example of a link time error message. And define reference to main. These errors are more hard to find, but remember, who is your friend? Here, a good Google search would be see undefined reference to main. I don't know why this first part. I don't know what this does on Google. Maybe I should research different parameters for Google and DuckDuckGo search, because that's also a very valuable skill. Because programming is based pretty much researching stuff online that you don't know. And the better you are at researching it, the better you are at finding the solution you want. And it gets harder when the problems are more difficult. Yeah, so I don't know what this does. Try compiling to find the link time error in some.cpp. It's gonna be main, I think. Some.cpp. In function start, undefined reference to main. Let's try again. So there's still something wrong here. This needs this symbol is this. The arrows are correct. It's not an infinite loop. So here's declaring I twice, but I'm not sure. Oh no, it's not declaring I twice. So I is smaller or equal to 0. So there's an infinite loop here. I is never gonna be smaller than 0. Let's try to run like this and see what happens. Yeah, now I can run, but oh, it's passing the thing. Alright. Shouldn't this be an infinite loop? Oh no, because the number is gonna be the input. But if it doesn't have an input, then I'm not sure. No, it returns some 0. I think it doesn't matter because it depends on the input of the user. So it doesn't matter this is an infinite loop. This only runs when the user makes the input. I'm not sure. Runtime errors. If our program has no compile time errors and no link time errors, it will run. This is where the fun really starts. Errors which happen during program execution runtime after successful compilation are called runtime errors. Errors occur when a program with no compile time errors and link time errors asks the computer to do something the computer is unable to reliably do. It happens after we give this command. We execute some common runtime errors. Division by 0, also known as division error. These types of error are hard to find as the compiler doesn't point to the line at which the error occurs. Trying to open a file that doesn't exist. There's no way for the compiler to know about this kinds of errors when the program is compiled. This is an example of a runtime error message. Point exception, core dump. There's a runtime error in ratio.cpp. This program is supposed to find the ratio of a table's dimensions, which is supposed to be 20 by 30. So it's division by error, the problem, clearly. Yeah, the issue is finding these problems on a really big program. Logic errors. Once you have removed the compile time errors, link time errors, and runtime errors, the program runs successfully. But sometimes the program doesn't do what we want it to do or not, or no output is proceeded. These types of errors, which provide incorrect output but appears to be error-free, are called logical errors. These are one of the most common errors that happen to beginners and also usually the most difficult to find and eliminate. Logical errors solely depend on the logical thinking of the programmer. Your job now is to figure out why the program didn't do what you wanted it to do. Some common logic errors: program logic is flawed, some silly mistake in an if statement or a for while loop. Note, logic errors don't have error messages. Sometimes programmers use a process called test-driven development, TDD, or which you give logic errors error message and save yourself a lot of headache. Let me just write down the topics that I went over so far. So I put later on the video title. Compile and execute steps.cpp. There should be no error messages. Steps.cpp. But the program is supposed to output steps from 1 to 10. The program is somehow starting from 0. So I think I should run the program. No. So it's obviously gonna be 1 here. The start. But then it's not gonna be, or maybe it is. Let me run again, see what happens. Yeah, now it's correct. So just changing from 0 to 1. Finding bugs is a huge part of a programmer's life. Don't be intimidated by them. Embrace them. Errors in your code mean you're trying to do something cool. This lesson I learned about the 4 types of C++ errors. Compile time errors, link time errors, runtime errors, logic errors. Remember, Google and Stack Overflow are program's best friend. For some more motivation, check out this blog post. Think about errors in your code differently. Optional because your friend didn't debug along the way. They ended up with a super buggy program. Can you be a bug detective and help them debug their program? Final program should print a fortune message like Flurry will go fortunate. So the first one that I see is the main. I also think I might come back to the Kagos course and learn SQL again because I might need in the stuff that I'm doing outside outside of the stream. So I think I'll probably need it eventually. So I think now that I have a more practical application in mind, I can learn better when I go back to do the course. So here, I think that's missing this stuff. I think that's the first ones I'm gonna look for. The easiest ones. Here's missing this. Here's correct. So for each line, it prints some phrase. Apparently all the arrows are correct. I don't think it's necessary to put arrows. Yeah, I probably can't put arrows after the else if, otherwise it's gonna cut the loop. Int fortune as runtime no. And now it's probably an error of the count. Suppose should be there we go for tonight. Just support should run this first one. So the remainder of random divided by 10 has to be 0. Which is not always gonna be the case. Because it can be 10 and then it's not gonna be the first phrase that is gonna run. So maybe I should just put 0 here. Nice. Yeah, another thing I'm trying to get better at is the communication between APIs and my local computer or servers in general. So I might also look for this kind of stuff before I start working on the AI library stuff. So from what I saw is Django and Flask, the frameworks used for that kind of stuff. And also I want to learn the integration between different languages. So I want to use Node.js and JavaScript to get information from APIs and then or from a website, and then run the Python code on the backend. And I learned some of the stuff on the Free Code Camp APIs course, but I don't think it was enough to really understand how things work. So I might think about a way, either some courses or a way to some project that I can do on stream and to try to connect both things. I think a project might be interesting, but I just have to think about it, which one to do. Introduction to vectors. To do just about anything of interest in a program, we need a group of data to work with. For example, our program might need a list of Twitter's trending tags, a set of payment options for car, catalog of ebooks read over the last year. The need for storing a collection of data is endless. We're familiar with data types like int and double, but how do we store a group of ints or a group of doubles? This lesson will start with one of the simplest and arguably the most useful ways of storing data in C++, a vector. Vector is a sequence of elements that you can access by index. That's pretty much a list. Creating a vector. The standard vector lives in the vector header. So first we need to add this line of code at the top of the program. Include vector. So vector is a library from C++, which the other languages don't have. So I assume this is one of the small difference from C++ to the other ones. They probably simplify this process. For review, include is a preprocessor directive that tells the compiler to include whatever library that follows. In our case, that is the standard vector library. In the syntax to create a vector looks like send vector type name. So to define a vector of ints called calories today, do this. Yeah, one thing that is coming to my mind right now is if it's only possible to create vectors of one type, then it's gonna become very, very difficult to program using C++. Because then I'm not sure how, yeah, that's very different from the other programming languages. Because a lot of times you're doing stuff using strings and numbers on the same list. If it's not possible to do that, then I think it gets way more complicated. So to define a vector of ints called colors today, inside the angle brackets is the type of the vector. After the angle brackets is the name of the vector. Note the type of the vector, i.e. what data type is stored inside, cannot be changed after the declaration. The Tokyo subway has different payment options for adults and children. We have declared a double vector already named subway adult. Declare another double vector named subway child. So it's just type define here and then the name. I assume is a list because that's what TensorFlow and NP call vectors. Initializing a vector. Now we know how to create a vector. We can also initialize a vector, giving it values as we are creating it in the same line. For example, instead of just creating a double vector named location, so subway, we can create an initialized location with specific values. So here it uses the object notation. This is interesting. Maybe it's the object inside of the list that this creates. Here we are starting a latitude and a longitude. So it looks something like this. Another way we can initialize our vectors by presizing or setting the size. Suppose we want to create and initialize a vector with 2 elements. However, we don't know what values we want to add yet. Here we are creating a double vector and setting the initial size to 2 using parentheses. It would look something like this. Because 0 is the default value for double. Suppose the Tokyo subway costs are as follows. I've initialized the subway adult already for you. Initialize the subway child vector with 400, 675. So it's just gonna be this. Yeah, I think now it starts to get complex. It'll probably take me some practice to become comfortable with this new way of initializing things. Note the vector can still be double even though the values entered are ints. That's interesting. So I suppose it works the same way as this function does, even though the function is int. Doesn't mean the stuff inside it's gonna be that. It's just, I think it's just the way that the compiler sees, puts this stuff in memory. So if you assign a vector to double, it's gonna put on a different place than if you assign it int. But that doesn't mean that the information inside is gonna be different. So that's very interesting. But I'm not sure. Yeah, I think the other programming languages they simplify this by making all the types of lists be, they don't have a specification for where the list is stored. So when you create a list, it might be an automatic process where the backend of the language decides where the list is going to be stored. So C++ gives you more flexibility in this way, which can also be a bad thing if you don't know how to use it. So I guess, yeah. I think it might be necessary to study more about the computer science aspects of it. Although I did a brilliant course on that, and I watched a bunch of videos about how computers work. But the compiler part and the memory, I think I know, but I'm not sure if I know in the text of the coding stuff, because they only talk about the theoretical part. They don't make the connection between the theoretical and the actual programs and applications, and which ways are better to store memory based on the different types of application you can have or functions and stuff like that. So yeah, I'm not sure if I know very well this side of things. Now that we have a vector, how do we access an individual element? This is where the index comes into play. An index refers to an element's position within an ordered list. Vectors are zero indexed, meaning the first element has index 0, the second index 1, and so on. For example, suppose we have a char vector with all the vowels. Should look something like this. Yeah, so same stuff from other languages. To output each of the elements, we can do vowels and then the index. Using the notation vector index with square brackets after the vector name and the element's index number inside. What is the element at index 2? The subway child vector. So it's gonna be 600. So now I think subway child 1. Oh, it's actually 750 because it starts at 0. Find out the answer about putting it out using standard count. I forgot this stuff. As always. 750. Next. Let me put vectors here. Adding and removing elements. Often we start with a vector that's either empty or a certain length. As we read or compute the data we want, we can grow the vector as needed. Pushback. To add a new element to the back or end of the vector, we can use the pushback function. For example, suppose we have a vector called DNA with 3-letter codes of nucleotides. It will look like this. We can add elements using pushback. So pushback is like append because it's putting in the end here. I'm mistaken. So what was the JavaScript? I think JavaScript is just push. Yeah. Dot push. And Python is append. If I remember correctly. So now the name will look like this. Dot pop back. You can also remove elements from the back of the vector using pop back. So I don't see this as the back. I see it as the front. But okay. Yeah, and it's removing this one. Notice how nothing goes inside the parentheses. The vector will now look like this because CTG is removed. Notice how nothing goes inside the parentheses. Oh, so it's not specifying anything. And now it looks like this because CTG is removed. If you have programmed in other languages, be aware that popback has no return value in C++. I wasn't even aware that popback has return value in different languages. Inside the code, oh yeah, I understand now. Because when you remove an item in all different languages, I guess that item can be stored in a variable. So in C++ you can do that because it just deletes the item and doesn't store it anywhere, I think. Inside the code editor, we have a standard string vector. So here, add these 4 strings using pushback. So it's the vector, not pushback. String hello. I'm not sure if I need to put string here. Probably I do. So here it doesn't have string, so I'm not gonna put it. I'm just gonna copy this. Ray, look. Yeah, works. So I guess you only need to... Yeah, I'm not sure. When do you need to assign a string when you don't? I think you only need to put string when you're assigning to a variable or something. Yeah, when you're creating a variable, then you use string. But because it's not a variable, it is the string itself, then you don't put it. Not only stores the elements, it also stores the size of the vector. So dot size. The dot size function returns the number of elements in the vector. For example, suppose we have standard string vector of Sonny's groceries list. So it's kind of like length. It should look something like this. The string at index 0, 1, 2 will return, so grocery.size return 3 because length is 3. Notice how nothing goes in the parentheses. Add a few more items to the grocery list using pushback. So grocery dot pushback. Banana. Apple. Potato. Print the size of groceries. Grocery dot size. Nice. Okay. So what happens when you want to change each of the values within a vector? You can use a for loop. For example, suppose we have an int vector that looks like this. You can write a for loop that iterates from 0 to vector.size. And here's the cool part. You can use the counter of the for loop as an index. Yeah, so it's very similar to JavaScript so far. That's what I'm feeling. It's a lot more similar to JavaScript than to Python, in my opinion. Here I should put this. And it has these annoying things where you need to put this stuff at the end of each line. Which I might start doing in other languages just to pick up the habit. Because if C++ is the closer to machine learning, then I suspect that putting these lines might be useful for it might be more efficient for the computer to know what the code is doing. Or it might be, because it doesn't make sense that it's just an annoying thing that they made people do for no reason. But sometimes people do stupid shit like that. This will change the vector to basically creating a loop to the vector. So this is not vector, this is delivery order. Just the vector here. Then it's pushing back these 4 values, which means it has length 4. This is going to loop through the vector. Here we incremented I from 0 to vector size, which is 3 during each iteration. We're adding 10 to the element at the position I. In the code editor, there's a double vector named delivery order that is storing the prices of some food items. There's also a double variable named total that's already declared and initialized. Double variable here, total. Write a for loop that iterates through the delivery order vector from 0 to deliver order size, and add each order to total during each iteration. Also, I should make total. I'm not sure if I can do plus equals. Delivery order I. Then this is gonna store this value in total. Let's see if this works. Okay, this works. Output the final. Oh, that should be outside of the loop. The final total is maybe is inside of the loop that they want. And I don't need to put this stuff here for some reason. I think because here is already outside of the scope of when the program is running, maybe. Congratulations, you have learned about how to store groups of data into vectors in C++. Here are some of the things that we learned. Vectors is a sequence of elements that you can access by an index. The first index is 0. Some of the functions that come with vectors: pushback, popback, size. So pushback puts an element, a new element, to the front of the list. Popback takes the element out. Size is the length. Use a for loop to iterate through a vector. Better program to find the sum of even numbers, and the product of odd numbers in a vector. For example, suppose I have a vector that is like this. So int main then I'm gonna have double num, maybe int num, better. Then I'm gonna have a vector. I think I forgot how to initialize a vector. I think it's vector, then the type here, which is int. Yeah, I forgot the first. So how do I do this? So I think the variable goes outside. Oh, maybe I don't need to initialize because I'll put it on the vector. Then I'm gonna put these things here. I'm not sure if I initialized the correct way, but standard, so it doesn't have this count and it doesn't have the zeros. Vector int, and it didn't initialize here with int. So I'm not exactly sure if you always do like this or if sometimes you specify the number. The program should output. So for int I equals 0, I is smaller than num dot size I plus plus. So I'm gonna iterate to the vector, and if num 0. I always get confused about if about which one is even and which one is odd in English. But I think that's gonna be the point. So it's either gonna be even or I think it doesn't matter. And I don't wanna look it up, so this is gonna be the same here. So it's looping through the vector, checking if it's divisible. Oh, it's actually divisible, not by 0, but by 2. And if it is, if the remainder is 0, maybe just putting like this is not enough. I have to make it equal to 0. Yeah, because this is just gonna give me the remainder. So maybe. So if the remainder is 0 is even, then I don't know exactly which one is even or odd because I don't remember English, but so num.size doesn't work. So maybe I'm initializing it the wrong way. So maybe I need to put int here. Let's see if this works. Still doesn't work. Vector is not a member of std. So maybe I should erase std. Yeah, it's definitely on the initialization part of the vector that is wrong. Just not sure what exactly. Was not declared in this scope. Oh, so oh yeah. Well, but num should be the name. Oh, it's because I didn't give the name of the vector. Uh yeah, I got confused because it shouldn't be num here, it should be the vector name. And num is just the items inside the vector. And then I should be using I to determine the index. But I don't remember how to specify the name of the vector. So maybe I should go back on the previous lessons. I'm gonna copy this so I don't lose it. So vector double deliver order. So the name comes after. Also num should be, yeah, num should be the name of the vector. but I still don't understand why it's not working here. Here should be I, then I. So maybe it's another mistake that I'm making. I put this stuff along the lines inside the loop as well. Hmm. Oh, nice. Thanks. Oh, but it's still giving me a mistake. I think it's the vector, the problem, because all these mistakes are related to vector. Count's not a member of STD. I'm not really sure. Maybe it's just a problem with the terminal, the back end of Code Academy. It's not a member of STD. So I think I'm gonna look it up because trying to think if I forgot something from the previous lessons that I should be remembering, but oh, but here is not including the stuff. But maybe you're right. Yeah, I have a feeling that is not. Maybe there's a space here. Yeah, it still doesn't work because in the previous lessons they initialize it like this. That's why I think it's weird. I'll go back. Yeah, so it's vector, double, and then the name. Maybe if I go one more lesson back. Oh, they has to you need to have std after the thing. Oh yeah, you're right. Also that I have to include vector. Include vector and include IO string. And I also forgot std inside of the thing. So yeah, it doesn't have this. But it does have this. I'm not sure if this is correct or not. Is it include or something else? No, I think yeah, I think it's just the hashtag without include. Or maybe let me try it the way you wrote there. No, I think it's just the hashtag. No, it is with the thing. No, but this doesn't work. Oh yeah, because it's maybe a vector thing. Both of them? Oh yeah. Now it should work, hopefully. Include a string. And it's still not working. So maybe I need to put int here now. Let's see if it works. No. Just int here. Nice. But I think I saw on the other tutorials that it had standard int there. Yeah, I'm definitely gonna forget this stuff. Yeah, here is standard string, which is weird because I don't understand why the other one doesn't need it, but here it is putting that. Yeah, thanks for the follow. And internet bird. Yeah, I wonder when I get to the object stuff, then it's gonna be really difficult. The function of functions. As a programmer, you'll find yourself reusing the same blocks of code over and over throughout your program. In times like this, you can turn to functions. Also known as methods or procedure, a function is a named group of code statements that accomplish something together, a bit like a factory machine. There are some great reasons to use functions in your code. A single line can make all that code far off, instead of a whole bunch of lines. You can build dry, don't repeat yourself code using the code you already wrote. Functions help make your code flexible and modular, meaning you can group your code more easily by task. In fact, every C++ program has at least one function. Hold on, maybe thinking I've written some C++ programs, but I haven't written any functions yet. Well, as it happens, main is a function that you've already used, and you understand it a bit more as you learn how functions work. Take a look at the IT support conversations in main.cpp. There's a lot of repeating code. Compile and execute the code. It works, but we could make this code much shorter and cleaner with the help of a function. So I think they want me to put some function here. Conduct IT support. Check in with gen. So there's repeating the conduct IT support here. So maybe I should erase this. But it's not exactly the same. Because here there's true. Oh, here's initializing, that's why it's not the same. But then do I want to initialize it inside of the function or outside of the function? I think I need to erase that and create a function here. And then I should call the function here. I'm also not sure if I should probably just call it like this. Maybe. Then checking with Jen, checking with Rome. Conduct at this part yet again. So I should call it here as well. So it didn't work. Checkpoint to turn green after the compile and execute. Oh, so maybe I'm missing this stuff here that I always forget. Let's try now. Take a look at. So maybe I wasn't supposed to do anything, just run the code. Or maybe if I just call it like this. No. So maybe let me try to do it this way. So here gives me the. So I think it's always better to try this one first. So for some reason this is not working. This part is not clear in the scope. So function definition is not allowed here before this token. So I can't have a function. I think maybe they just wanted me to run the code, but I'm not sure. Because they didn't talk about how to initialize a function inside another function. So I think I'm gonna try to run it from the beginning and see what happens. Yeah, no. So I have to do something. So clearly I have to erase here this shoe and build a function here. And see if they talk about something. You may be thinking main is a function that you already use, and you understand it a bit more as you learn how functions work. So I'm just gonna put sparks. This is easier. But now is the question. They also didn't talk about what's the difference between initializing functions using int and using other stuff. So I think something along these lines should be what I'm supposed to do. The indentation is correct. I don't think there's any arguments because they didn't talk about that as well. Let me try to run from here to see what happens. Oh, now it works. But it's still giving me a mistake. So what if I run? Nice. Yeah. So maybe there was a typo before. Built-in functions. Before we learn how to create functions, let's go over some built-in functions. C++ comes choke full of functions that are already created as part of the standard library. How do we access this hidden hoard of helpful functions? You can access to various functions by including headers like cmatch or string. In fact, you may already have used a couple functions without even knowing it. With the following header, include cma. Gain the power to call square root to find the square root of any number. Wait, call square root. Calling a function is how we get a function to take action. To call a basic function, we just need the function name followed by a pair of parentheses like square root 9. For example, square root 9. I'm also thinking that it might be interesting to research about how Python is built on top. I think it's built on top of C++, if I'm not mistaken. That might be something that I search for. To understand how these libraries are built. So I think I read this. Inside of main, call rand with the module operator to generate a random number between 0 and your favorite number. So srand, maybe? No, it's rand. They want me to call. For example, rand, yeah, would output a random number between 0 and 28. Assign the resulting value to a new int variable called the amazing random number. So int the amazing random number is going to be equal to rand, and then I assume that I have to import the library there. And I assume the libraries you import on C++ are probably machine code, because that's the only thing that is below C++. So oh, I forgot the thing. Print the amazing random number to the terminal. So that's gonna retype everything. I think that's it. And then I have to include something here maybe. I'm gonna try without including it. See if it passes. Yeah, nice. So that's it. Declare and define. Often built-in functions aren't enough to tackle the wide array of programming challenges out there. But never fear, you can write your own functions too. A C++ function is comprised of two distinct parts. Declaration this includes the function's name, what the return type is, and any parameters. If the function will accept input values known as arguments. Definition, also known as the body of the function, this contains the instructions for what the function is supposed to do. This is the overall structure. This is what it might look like with real code. So, return type. Watch how the make sandwich function gets executed step by step. This is just a preview of how everything works, so don't worry about memorizing anything. In exercise, we start building functions from scratch. So it is not very different from other programming languages. So yeah, parameter is inside. I don't understand what's this return type here. If it is just an explanation from the explanation. Yeah, return type, output if there's any. No, and I didn't put a return on the previous one, so the previous exercise. So I don't think it's always necessary. Void the point of no return. Let's build a simple function with no input and no output. We can do that. Enter the void specifier, which is added in the function declaration before the function name. A void function, also known as a subroutine, has no return value, making it ideally suited for situations where we just want to print stuff to the terminal. So void animal chat. Void specifier. The above chat, so this is better for when you don't have returns. I wish they gave the explanation, but it's probably true. It's probably unnecessary because it probably involves machine code, and then it might be just a waste of time to learn because it's too complicated, even though it might be interesting as well. The above chat program is built to capture user responses and print to the terminal without returning any values. Above main, define a void function. So void Oscar, wow, it's cool. That prints the standard counts. The highest and the highest as the lowest form of criticism is a mode of autobiography. Forgot the dots. So I think this is it. So I made some mistake. Include something maybe. Wild quotes. Nice. Okay. Set up main, call Oscar. I wonder if they're gonna explain scope as well of execution. Return types. Beyond the void. When you do in fact want your function to return something and pass information back to the rest of your program, C++ has you covered. Just like there are many variables types, there are many different return types of functions. Function can return most data types we've covered, including double, int, bool, char, string, and vector. Note the return statement is the last line of code that our function will execute. For example, yeah, so it's very similar. The final will not execute. Convert needs it support provide function into a bool type function. So I think it's just changing here. Then run. We're currently printing support at the end of the function. Where? So I think it's here. Currently printing support at the end of the function body. Remove the print statement, instead return support from the function. So instead of this, we return this. Instead of main, print the result needs it support to the terminal. So I'm not sure if they want me to do a standard count here. I assume yes, but I'm gonna try to run it like this. Yeah, so they want me to do this probably. Yeah, correct. How return values work. When functions have a return type other than void, the function has two new requirements. There must be a value returned from the function. The return value must be the same type as the function's return type. But where does the return value get returned to? It gets returned to the place where the function is called. For example, if I have the following function and then print the function call inside of main, the return value of the function is what gets printed to the terminal. So let's see if I really understand this. Watch how make sandwich passes return value back to the function call in main. So this is a return type and this is a return statement. I'm not sure if I understand this animation. So I think this is the beginning of the program. Make sandwich is a function. Return sandwich. Oh, so this makes sandwich. Oh, now I get it. Because this is inside of this function here. I think this is important to understand. That's why I'm not going fast. I think the most important things to understand, which I still don't understand very well, is scope of the execution, parameters, and this statement when you want to pass values and maintain the same value in different functions. It's the hardest, most confusing thing to understand so far for me. So I think it's worth to not go really fast over this. When a function have a return type other than void, the function has two new requirements. There must be a value returned from the function. So when the type is not void, there must be a value returned from the function. Which is weird because the other exercise I didn't put the return value and it still worked. Well, maybe I did put the return, but I don't remember really well. I don't think I did, but maybe, yeah. The return value must be the same type as the function's return type. So whatever you're gonna return should be the same value, the same type as the function, which is very different than other languages. Where does the return value get returned to? It gets returned to the place where the function is called. For example, if you have the following function and then print a function call inside of main. So I have this function here, which is a string. And then it's interesting that it's declared with std here, which is different than the previous times. The return value of the function is what gets printed to the terminal. So this is executed here, and then the return is printed on the terminal. Yeah, makes sense. So the only difference is pretty much the type of the return has to be the same as the type of the function that is declared. And I think that one of the reasons this might be the case is because it's probably more efficient to store in memory that way, because then you're gonna put the function in the same place you put the value that is returned, which makes the program faster. And I assume that in other programming languages, it might be that when you have a function that doesn't have the same type, the return is not the same type, then the function is going to be stored someplace in memory that is different than the return value, which is going to make things slower, I think. So that might be the reason why it is that way, but I'm not sure. Parameters and arguments. Returning data is all well and good, but let's say you're visiting New York and you've been told that New Yorkers usually add a 20% tip for restaurants and taxes. It would be really convenient if you could just build a function that accepted different prices as input and figure out how much you should tip. As it happens, you can do that with parameters. Parameters, sometimes called formal parameters, are variables used in the function's definition. They act as placeholders for the input values you use during your function calls. In the function below, price is the function's parameter and it's a double. So that's, yeah. Double is interesting that you have to put the type of the parameter as well. I guess that in Python you also have that when you make it equal to something as the default value. But I wonder if you can put it without specifying the type. Price is the function's parameter and it's a double. So I wonder if in other languages is better to always initialize parameters when you're making the function. Is declared between the parentheses and then used in the body of the function. Then when you're ready to use your function, the value passed to the function is called an argument, also known as an actual parameter. In this case, 15.75 is the argument that is passed to the function. So let me see how much time is 17 minutes. Then we'll get the, yeah, so it's passing this value to the function there. You work with emergency services in Britain, and their emergency number just changed. That's a big change. What if the number changes again? Let's build a function that prints out the current emergency number, whatever it is from now on. So original emergency service number. Here, time and better looking driver. New emergency number. Call get emergency number below with the number you want. So I need to define here first, which is gonna be, so it has to be a string because I'm gonna return a string. And then I need to put this stuff then. Then I'm gonna pass a parameter, which is gonna be string number, which is gonna be a string of the number. Then I'm gonna return, well, maybe I should put new number. Return new number. And then here I'm gonna call it get emergency number and pass these arguments. And I don't think I need to put string there. But when we define a function that accepts one parameter, a string with the name emergency number. Also, the string needs to be emergency number. So let's see. So this declaration is wrong for some reason. Maybe I can't have string as a parameter here. String does not name a type. Did you mean? Also, maybe I need to put this. before. Let's see if it works now. So here now is a problem. So I'm not sure. I think it was specified here. Hmm. And it's also not using std here. But I remember on the previous one he used. Yeah, the emergency number. So let me think. I can try without it and see if it works. String was not declared in this scope. I think the error might be here, actually. It's more likely that it's here than that is here. I don't think I need to include anything because I'm not using vectors. Let me try to put a different name here and see if it works. Then know if it works or just look at the solution. String was not declared in scope, so might be here the problem. Let me try like this. Yeah, now it's giving me the mistake there. So let me try it like this. And now it's pointing here. Yeah, so I'm declaring it wrong for some. I'm not sure if I should put on the return as well. So this is how I think it should be. So maybe if I read this again. As it happens, you could do that with parameters. Parameters, sometimes called from parameters, are variables used in functions definitions. They act as placeholders for the input value you use during your function call. So I have to specify here and I have to specify here. I don't think it's a problem with the return statement because it's not stopping there. It's stopping before. Oh, it's a void. It's supposed to be void. And now it's string the problem. So maybe if I erase the. Yeah, I don't understand this. Maybe they just want me to initialize it without any values and then call it passing it, but that doesn't make sense because it's not the point of the lesson. Oh, So I think what they want me to do is this. Maybe. And then do something here instead. Get dial emergency number. Should get emergency number. I really don't understand this part here. So maybe I'll just write as it says there. Yeah, but that doesn't make sense at all. In my mind, at least. Dial. Because it doesn't make a lot of sense to pass this as an argument. But maybe that's what they want me to do. So now at least there's less mistakes. Expected before token. So I should erase this maybe. Yeah. Let me see if I erase this. No. Yeah, it has to be a function. So I don't think this path is correct. So I think this should be on the return message. And maybe they want me to return like this. Pass the string. And here just pass the thing. That makes a lot more sense to me, but doesn't seem to work. So maybe it's the way that I'm passing the argument is, and yeah, but that doesn't make sense because this part gets run first. Let me read the last part. Oh, it's passing now. This one. But it's still giving me a mistake. Let's build a function that prints out the current emergency number, whatever it is from now. But main define a void function get emergency number that accepts one parameter. String name with the name emergency number. Get emergency number print out dial with the emergency number that was passed into the function. So maybe I should erase this part here. Yeah. Because the return already prints the thing. But I don't think this is, well, it passes. But that's weird. Maybe it's a problem with the terminal of Code Academy. I'll get a emergency number in main to see the number get printed. So this part is not working. So maybe I should pass string here. But that doesn't make sense because it's already initialized here. Let me go. See what happens. If number is an argument. Oh, it passes now, but so I think I had this problem before. I think it's just from a problem with the terminal on the Code Academy. Because sometimes it gets stuck when you make a mistake initially, gets stuck on that mistake. But I don't understand why it's void there and not a string to initialize the function. If the return statement is going to be a string. And if void functions are for when you don't want to return anything. Oh, maybe I was supposed to do. Yeah, maybe that's what's wrong. Let me go back. I think I wasn't supposed to put a return statement. That's why. That's probably the problem. No, it's still giving me a mistake. It's interesting that it's passing though. I wonder if they have the solution here somewhere. Maybe it's this cheat shit. No, this is just a summary of what I learned. Function that returns a value must have a return statement. Parameters, functions, built-in functions, calling a function, void functions, function declaration and definition, scope of code. Scope is the region of the code that can access or view a given element. Variables defined in global scope are accessible throughout the program. Variables defined in a function have local scope and are only accessible inside the function. So another thing that I remember now is that I've learned, I think was on the brilliant thing, that it's better to declare more variables. I'm not really sure about this, but I think that's how it works. You shouldn't you should try to declare at least the least amount of global variables as possible because of the way that is stored in memory. It's more efficient to declare local scope variables more often than to declare one global variable and then reuse it in a bunch of different functions because of the way that the functions and the variables are stored in memory. Function declarations in header file. Yeah, so I'm not really sure. Maybe I should just move on to the next one. But I kind of want to figure out what's wrong here. If there's something wrong. And I don't feel like opening Visual Studio and trying because I don't really know how to use it yet. I don't know how to use it really well. Just see to run the programs. Declare void. Oh, I forgot the count here. Now that I erased return. So maybe that's the problem. But it still doesn't work. So maybe if I erase the string now, it's gonna work. Yeah, let's try to put this. Probably not gonna work. Yeah, so the timer is up. Mm. Yeah, I don't think I'm gonna be able to figure out. String was not declared in this scope. So maybe I need to put, but I was gonna say I need to put this stuff here, but I'm not. It's probably not gonna work. Oh, now it works. Nice. So I was missing this stuff here. I also don't understand really well what this does necessarily. Maybe they're gonna explain it on the course. If they don't, I'm gonna research for it. What these two dots and I know that count stands for character out and sing stands for character in. And then you use, I think is, I maybe I should look. I think I'm just gonna look for that and then I'm gonna be done for today. CD, a namespace. The operator is the scope operator. It tells the compiler which class namespace you're looking for an identifier. Send call tells the compiler that you want the count identifier and that it is in this std namespace. If you just set count, then it will only look in the global namespace. This count isn't defined in the global namespace. It won't be able to find it, and it will give you an error. Using namespace std, tell the compiler take everything that's in the std namespace and dump it in the global namespace. This allows you to use count without the std prefix. Interesting. But it increases the probability for name conflicts, since a bunch of extra names that you didn't expect also got added to the global namespace, and that might butt heads with some of your own names. Not sure if I really understand the last part there. Stands for standard, as in the C++ standard library. So it's pretty much a library, and the two dots make the count be assigned to the library. So it is on the scope of the language, if I understand correctly. But I'm probably gonna be looking at more in the future. I think I'm done for now for today, and I'll probably come back either tomorrow or some other day to continue to learn this. Particle, what's part about global namespace? What do you want to know? If you want to know something, tell me now, because I'm gonna be doing other stuff off stream. There's a lot of stuff in SD, so using namespace SD makes it pretty likely that you accidentally use something you didn't know is there. Yeah, and I don't understand really well what that means. He's saying, I think what he's saying is that if you specify, if you do the command that he talks about there, and so you don't have to use the std every time, then you're gonna pick up a bunch of stuff from the library that std is, which is gonna have a bunch of variables that are gonna be now in the global scope instead of the local scope of the library, if that's correct. I think that's what's happening. So probably on the library have a bunch of functions with a bunch of variables inside of them, that are used to do this stuff. Yeah. And then when you call the library, when you make the library, when you make it so you don't need the library, then all those variables, instead of being local variables of the functions, become global variables. But I still don't understand why this happens. But it might be actually, it just might be not practical to learn. Because I think the only way to know how C++ learn works is to learn machine code. And then I'm not sure if I want to know, I want to study machine code, but I think it might be just a waste of time. Because it might be too hard and like kind of pointless. Use a namespace is handy if you want to avoid repeating explicit prefixes. So namespace is the command to generalize standard, right? STD. If you want to avoid repeating explicit prefixes, yeah, it gets annoying. I imagine that in very large programs, it would be really annoying to just write standards all the time. And also this sign here that's also annoying. But using namespaces, these generally considered bad taste. It's kind of like importing with a star in Python, right? Because people say that is bad because they're not specifying which library it's coming from. Standard is the namespace part. You can make your own namespace my stuff. Make your own. So the namespace, you say the two dots. I don't understand what you mean by standard is the namespace part. So my stuff is just the name of the function, right? So if I understand what you mean, you're saying that standard is like this, like a function, and then inside of this function, there are a bunch of other functions, right? And then when you call count or anything with this operator tells apply this thing inside of this function here, which has a bunch of other functions, right? So the string should be a return from the, should be a parameter maybe from standard. The standard has these parameters like count, scene, string, and then etc., which are these ones that you put here, and then you run some code to print whatever you wanna do to get the input or to output the input, right? Is a separate concept. So I think I'm gonna write this here to research later. Oh, so it's kind of like a method. Kind of like string or the other ones. Prefix to names of global things, functions, classes, whatever. Yeah, I get what you mean. Yeah. Can you declare a function with namespace? Yes, they're doing here. But then that leads to the question, what is namespace and how it works? It's all compilations of machine learning code, right? So it it is basically a Tower of Babel thing, where you have the very basic logic, which is the circuits with the transistors that make the hardware logic. Then from that, you're gonna have the zeros and ones from machine code, and then people figure out how to build a sequence of pretty basic but more intelligent logic than the logic gates from the hardware that becomes these things. And then to understand namespace and the very basic levels of C++, you probably have to understand how the zeros and ones are combined with this which is machine learning code, right? I think that's how it works. It's just a method of grouping certain things together so they have an explicit prefix and don't get mixed with other things. But how does that work? That's the question, right? Because it is not a function, right? Or how is it built? Like what happens on the computer when you run namespace? How it's running in the memory? Completely different thing. Concept of the language. But let's say the program is running, right? And then it gets to the namespace part. What happens in memory? Or it's too complicated to say. There are no names at machine level. All the names are just something the compiler understands to make things more human friendly. Yeah, that's what I'm saying, right? So namespace is the lowest level or whatever, like string and these types of thing, right? In C++. From there, it's all the compiler doing stuff. Or no, or understanding this incorrectly. So the way I understand it is you have the C++ program, and then you have the compiler, which is another program, which learns. The compiler knows machine code and translates the machine code into the language, right? And the other way around as well. The namespace itself has no effect on code whatsoever. Literally just a way of grouping certain names into a collection. And what's the type of the collection? It's just for human organization purposes. So the machine doesn't understand. Like, that's the difficult part for me. When does the zeros and ones become the first language? How is it grouped together? It has to be a series of logics of AND OR gates and XOR. AND gates, OR gates, or XOR gates, right? That initial statement. What is the meaning of that thing? It's really difficult to understand. And then from that, you get namespace and all this other stuff. Several levels of abstraction between what you write in C++ and what the machine actually does. Really? Isn't just the compiler? I thought oh no, there's assembly as well, right? But I thought that C++ was the low. I'm not sure if they say lower or higher, but the closest thing to a language, let's say, from the machine code stuff. So there's C++, then there's assembly, and then there's machine code, right? So C++, in my understanding, C++ is built on top of assembly, which is built on top of machine code. And then all the other languages are built on top of C++. Or, yeah. But I'm not sure if that's correct or not. Human readable version of machine code? Yes, of course. And C++ is built on top of assembly or not? Yeah, it's very interesting to think about this. Because you can think about the human brain the same way. It's just a bunch of signals that get together somehow and become more complex stuff through the interaction of them, which is very crazy. C++ is low level compared to many other high level. So low level is close to the machine learning code, but it's not that close to assembler. There's quite a bit of translation involved in the compiler. Do you think it's worth it to study compiler, or is it just waste of time? Because I kind of want to understand, but I'm not sure if I'm sacrificing too much time by focusing on that instead of the practical. Because once you start looking at all the libraries and stuff, you kind of want to learn everything, but it's just too much stuff to learn. You know, a lot of the things you just have to accept that you're gonna use a bunch of code that other people built, and you're not really gonna know how it actually works behind the scenes. But do you think it's worth it to learn? Do you regret it learning or not? Like, my goal is to build artificial intelligence. I want to build my own artificial intelligence library, and I want to try to solve complex problems using this library. So it's always a there's always a discussion on my mind on if I'm wasting a bunch of time learning about a bunch of stuff that doesn't matter because we don't have a lot of time anyway, and if I should just be using the libraries. The whole point of learning C++ is just because of that, because I want to understand more how everything is integrated. Yeah, I know, but yeah, I understand that is very different. But do you think that understanding the concepts of how the compiler work might be beneficial when trying to think about how to structure a neural network? Because I feel like the more I learn, the deeper I go into the language, the more I actually learn how the computer kind of thinks from the ground up, let's say. Not really. because even though it's not the same thing, it kind of actually is. Like, it's obviously connected because the hardware becomes the thinking the machine does, right? Like, everything works on the basic logic, which is the foundation, which is the hardwares. And that's the electricity and how it connects there. That's how I think about it. So when you're thinking from a high level of feeding the data and that stuff, yeah, but I'm not really sure if it's useful or not. Think about things in different ways. But it can be a waste of time, right? It's just stuff, man. There's too much stuff to learn. And not a lot of time. Yeah, exactly, but it's all connected, right? That's the thing. Because computers are all about math as well. Because physics is about math. Physics is applied math, which is logic. And because the thing is, the reason people can't figure out machine learning problems, I suspect at least, is because they don't have a good understanding of how the data relates to the problem, to the way that the algorithm is learning, right? A big number crunching machine. But you could say the same thing about neural networks, right? They're just a big gradient descent thing. They're just fitting lines into points, basically. That's the thing. In a way, I think it's very similar, but at the same time, it's very different. But I'm not exactly sure how it is different. You know? I think that what the difference is the logic, basically. But because I don't understand the way the compiler works, I don't have the clear picture of what things the compiler is doing that is different than what the machine learning is doing. Well, at least the machine learning that I know so far. I don't think that I know really well the more complicated ones. The evaluation of the neural networks on a computer, that is like pretty much pure linear algebra. Yeah. But do you agree that there is a flow of information there, right? Like, there's the electricity coming into the computer, to the hardware, then it becomes the logic, then it's translated into languages, and those languages become functions that approximate inputs. So the way that I see it is a loop, which is pretty similar to the way that we think, because I think that the internet is just an extension of us, right? You have impulses, then they become abstractions, then these abstractions become reality through actions. So I'm not sure, maybe, yeah, but in a practical sense, I'm not sure if it is worth it to, like, an analogy would be, is it really worth it to know how the brainstem works should know how to think better? And I think that's a very difficult question to answer. Because if you do understand it, then you'll be wiser, I think. Because you know the ground foundations of the way that why you're behaving the way that you are. But in another way of looking at it is just a waste of time because it's not gonna help you drive a car, for example. So that's the way I see it, I think. And compiler might be just too primitive, let's say, to really spend some time learning it. But it might be the case that is worth it as well. I'm not sure how to draw the line. If it's worth learning how compare, I'd say definitely. And do you know about AI or you don't care about AI? I think, yeah. Maybe after I learn C++. I think there is so much stuff that I also need to learn as well. Like SQL and the other things. So maybe I'll learn. There are any courses? Do you know about any courses that teach compiler stuff that I could do on stream? Because I found that is a lot better to do courses on stream like this. Because coding usually is a lot better to code using two screens at the same time. But then you have to put one screen on the stream stuff. So I think it's better to learn stuff that I can do only one screen on the stream, and then outside of the stream I'm doing a bunch of other stuff as well. If you're asking if it's useful for machine learning specifically, I don't know. They're not closely related at all. I know enough to implement a basic neural network. Sort of recommend that trees. Alternatively, virtual versions of that trees if you want to be more environmentally friendly. Not sure if I understand what you mean by that, but is that trees an algorithm? I know there's trees on machine learning, like random forest, and that kind of stuff. Classics, yes. Introductory text, structure, and interpretation of computer programs. Is available on the web for free. Nice. But is it true theoretical? I think I'd rather have something that I can also code or try to do stuff because it's better to retain in memory. Is this it? That tree equals printed books. Oh, I got it now. Where did you say that? That's an interesting way of telling me to read books. I'm actually reading a book right now about artificial intelligence as well. SICP is a scheme as its programming language, but it starts from the very basics and goes through all the way to how compilers essentially work on high level. Also, it's the same course you're talking about. Oh, but do I have to pay? Yeah, I think this is a book, not a course. Maybe I'm opening the wrong stuff. This one. So these links here. To the previous page. This one. Which of these links here? Put text in each. Oh, here. This one on top. Or this one on the bottom here. Page not found. Oh, so now this is the course. Or it's a book. Yeah, I think this is it, right? Then I can just press next here. Keep going. That's the thing. Yeah. But is it? It's a book with some instructions. If I understand. Yeah, programming in Lisp. Yeah. Okay. I think I'm gonna think about it. I'm not sure if I'm gonna do this. I think I have to think more, spend more time thinking. Maybe after, because there's so much stuff to learn. I'm gonna learn C++ first, then SQL, then Django, I think, or Flask from Python. But in a nutshell, the compiler will first parse your source code, just a sort of expressions in memory that are then transformed a few times to lower level representations until they can be converted to machine instructions. Yeah, that's how I imagine as well. Like the theoretical stuff, I think I understand, but just yeah, just really understand. I don't think I do. Yeah, For a language like C++, it's actually quite a complicated process, because most concepts you have on language level are not something the machine implements directly. Rather, something the compiler has to lower down to machine level. Yeah. But I think it's better because the thing is, C++ is a lot more practical, right? So I think it's better to start learning with C++. And then after C++, I have to decide, because machine code is probably definitely not practical at all, but it's definitely, not definitely. Maybe it gives me more insight on how everything is structured. Machine level, there's no concept of any types, just raw data and integer floating point operations on that raw data. There are no objects, just a big flat address, space of memory. I think, yeah, that's the interesting part, I think, is understanding how the numbers become the first concept. You know what I mean? I think that might be worth it to understand. But it seems like it probably would take a lot of time, because you said 6 days that you learned this. So maybe it's just not a lot of time. Because I want to understand how electricity becomes concepts and abstraction. And I think that closes the loop. Yeah, I think goes back on itself, because that's how everything works. Like the beginning is always the end. So I think machine learning, on the broader sense, is just the same way as machine code, but in a completely different way, because that's usually how it starts. It's like when a kid is born, he doesn't know anything, then he learns a bunch of things, and then at the end of the life, it forgets a bunch of things. So in a way, it's closing the cycle and it's going back to where it began. And I think all of the things do that. So in a sense, the machine code is probably very similar to the way that neural networks think, but in a completely different way at the same time, if that makes sense. Uh, there are no objects, just big flat address space of memory. What is a background in programming in general? It helped me give a suggestion on what to learn. I started 10 months ago, I think 11 months ago, and I learned everything on my own. But before I started that, I started learning to code. I actually knew a lot about, not knew a lot, but I've read and studied a lot about computer history and physics and math and a bunch of other things. So it's not like I was a complete beginner in the broad sense, but then I learned, the first thing I learned, I think, was HTML, then CSS. I went through the whole free code camp stuff, and I did the first part of the Odin project. Then after that, I started learning Python. I also built, I think, one or two sites, very simple sites from the projects. They tell you to build stuff. Then I also worked on some stuff on my own with Python, but not very complex stuff, very simple. And now I'm learning C++. What sort of programming have you done? Just writing basics. I only used classes and, yeah, classes when I did the free code camp stuff. I never did a project where I had to use a bunch of classes. I wrote stuff on multiple files, but I never wrote a full thing, full application, like front end and back end. You know what I mean? And that's also one part I'm having a lot of trouble with now, is understanding how the languages connect, because there's not a lot of information out there about that. Like there is some stuff, but nobody really talks about how to integrate everything from the beginning to end. And that's what I'm thinking about studying as well after I study C++. Do you have any suggestions? Do you think might be interesting? I think I did all of this stuff. Write complete applications in a lot of languages. Yeah, I think that's the best way, right? And then I just research along the way when I get stuck. But what do you think are the best ways to learn about this? Because I've seen some videos on YouTube that they talk about how to integrate Node.js with Python, but it's not very. They just tell you to use a function there and then run the Python below. So there's not really something that shows the integration necessarily of everything together, at least from what I've seen so far. I think maybe I've heard about Django and Flask, but I still think that Django and Flask is just Python. It just is not the integration itself. And I think I have a good grasp of the theoretical concepts now, but I don't have uh, when I'm trying to do stuff on my own, it's kind of hard to research about this. It seems like I get stuck a lot on this part. Node.js, yeah, that's fine. But with other languages, you know, I don't. I mean, I don't care about the language as well. I care about the integration because everything you need APIs to communicate, and then maybe I want to build a site that displays information as well. So the tutorials I was seeing was using Node.js, but I know there's a lot of other ways, right? Because Node.js, I think, is a backend language also, or is the backend for JavaScript. C++ personally, which has direct access to native APIs. And then do you write everything in C++? Do people usually write everything in one language? I'm trying to think. Trying to think about an example I can give you. Yeah, because even if you use C++, when you get information from the internet, it's going to be another format, right? It's going to be either HTML or JSON or HX, I think. usually write everything in one language unless they want to have a higher level and lower level language for some reason. Mm. What language for the front end you use? If you Yeah, but you said you don't have a lot of experience with websites. It's not that uncommon to glue Python and C++ or Lua and C++ together, but I'd say that's sort of an advanced thing to do. But let's say I think people do use different languages when they are connecting the front end with the back end, right? I think the most common ones are JavaScript for the front end and Python for the back end. Web, you're kind of forced to have both client side JavaScript and server side, whatever you want. Generally speaking, your life is more simple, just one language. I remember the name, API wrappers, I think. Understanding how API wrappers work. That's the thing. And I think that the thing that teaches you that is Django or Flask, right? Or Python. I'm not sure if C++ has a framework for that as well. Because the main issue is the API itself, understanding how the API works. If I just have the API documentation, or maybe if I don't have any documentation at all, and I'm trying to extract something from the web, like how do I search that? You wanna do web dev, then I highly recommend you forget C++. No, I don't wanna do web dev. It's just for the API stuff. Let's use Twitter, for example. Because they have a lot of wrappers, but if you just wanna learn how to directly communicate with, I've seen that they have a couple of libraries for that, but usually there isn't like there isn't many tutorials about that fully complete on one language only. So there are a bunch of tutorials talking about some things, but they don't give you the full picture of how it works in the background. So that's why I thought that it might be better to understand how the concepts work so I can do it every time without relying on a wrapper, or I can just read the documentation of the API and know how to communicate, you know. Or even if a site or something doesn't have an API like Wikipedia, but I wanna get some information from there, how can I get it and use stuff? And I wonder if C++ has that as well. And I was also looking, when I looked at that, uh, there's a function named inspect for Python. I think no, it's not a function, it's a library named inspect that you can read code. So maybe that's what I would do. You can see where the file of the library is at, and you can read all the functions and try to figure out. Every operating system and platform, once not, it has its own API. There's about 200 of them. Yeah, but sometimes sometimes a site doesn't make them available, right? Like you have to write a web scraper to get it. And then there's the library Beautiful Soup for that. So I guess you can do everything with Python, maybe. Basic window in a basic C++ application. Then the API you need is known as Win32. Really? No, let's say I want to get information from Twitter, right? How would you do that? Like, what kinds of things do you search for so you learn how to do it without any wrappers or without using other people's code? Like, imagine you just reading the documentation here. I forgot where they have. Maybe it's this one. I'm just gonna click on anyone that has the codes. I did manage to do it, but I used the TweePy wrapper, and it was very hard because there's not a lot of people that explain it really well from the beginning. So, like when you use the wrapper, is not the same methods as when you're just reading documentation directly. When you use the documentation directly, you have to do a bunch of other stuff that I don't understand really well. You always be using other people's codes. Yeah, yeah, I know. But the issue is not using the other people's code. It's just a lack of understanding when I'm using the code. You know what I mean? Because when I put TweePy there, then I have to search for the TweePy library, and then like there's a bunch of other libraries, and you don't know which one's best. But what I want to be able to do is just get here, documentation, read the stuff, and then I apply it without looking at anything else. Like I just know what to do. Low level way to talk to something like Twitter is to open a socket, which is basically a raw TCP IP pipe, and then send an HTTP request to that socket. Yeah, and the normal one is WebSocket, right? The library. Not planning on writing our own network drivers. Yeah, I think that might be a bit too much. We're doing it from JavaScript running in a browser, then WebSocket is our only option, I think. That's the thing. There's different ways, right? And I don't understand really well, so I'm probably gonna say something stupid, but it seems that the implementation from Node.js and from Python is different when using the WebSocket. And then I also don't understand because usually the way I've been doing that now, I just run one script at a time, but I'm not sure if that's how programs actually work, or if people build one file with to run all the scripts in the sequence they want, and then they keep that file specifically looping, which is gonna activate all the other scripts, or if it's possible to run multiple scripts at the same time. Web browser itself will translate that to lower level OS socket calls. Yeah, I think I understand. I mean, so do you think that for both for Python and C++. For Python, it's better to learn Flask or Django to communicate directly. And for C++, I have no idea because I didn't search. The platform you're programming for myself. For example, when you write C++, you typically write native code for a specific operating system. Oh yeah, yeah. That also makes a difference, right? But I thought you didn't make a difference in the socket part of the thing. Writing JavaScript that runs in a browser is the browser that is the platform by implementing a virtual machine. Interesting. So the browser kind of acts like a computer in a sense when it's getting the code. Understand? From your client side, JavaScript point of view, browser is the computer. And then Flask and Django or Node.js or these types of frameworks are the libraries that are used to implement or the frameworks that are used to implement these requests, right? This kind of sort of a standard way to do it in a way. Where I think for Node.js I was seeing is you make const request equals require request. And then you usually make an app that is equal to that request object, that request constant. Yeah, you make it as a function, request, and then the parentheses. And then you use that app with the strings here. And then you pass the parameters with request. Then you use request and res to do the stuff in the code. But if I want to run a script that is very big, or is a program, for example, that goes outside of the scope of the information I want to get, then that's the part I'm stuck, I think. It's just understanding how to get the data. Like, it's going to come in a JSON format. Then I just get the data and I stop that part. I just go to the more complex stuff. Like writing informations through data frames or doing a bunch of calculations or other stuff from other scripts. So I think that the way that I'm thinking now is that I get the information from the server. Then on that request, I run a file from Python, maybe. So I maybe use Node.js or Django or Flask, contact the API, get the information with JSON, then parse that information into whatever format Python's going to use. Then activate the function, the script that I'm writing in Python. And then it's all Python parts. I think that's the way that works. So now it's just a question of which framework I'm going to use. And I think I'm going to use Flask, but for C++, I'm also not sure what framework. If there is a framework, probably there is, because people have built it. And that's the stuff I'm doing right now with Python. Not necessarily I'm doing with Twitter, but with other sites as well. To get information to run a bunch of machine learning systems and try to figure out ways that we can prevent the self-destruction from exponential attack, which is just pretty much seems like an impossible problem, but yeah, I think I spent too much time already here, past the time that I was supposed to go to this. I'm gonna come back some other time and continue this. Then after I finish this, I'm gonna think about it. And I'm probably gonna learn Flask off stream. Then I might try to build an application on stream. That might be the best approach. Is there interest in machine learning with the actual mechanism of how it all works, or on actual machine learning of something? No, my biggest interest is, well, first obviously make money. Obviously, everyone wants to make money. But more important than that is figure out how to create a better system than money. Because we need a new system, or otherwise we're gonna collapse eventually. Either that, or nobody knows what's gonna happen because of the singularity. So that's unpredictable anyway, so there's no point in trying to do anything about it. But to the extent we can do something, I think we need to change the systems we have, because with exponential attack, the imbalances in the system are going to become more clear, because power amplifies the imbalances. So we're going to have something like Facebook, which is like nothing really changed in human nature, but Facebook amplifies the imbalances of human nature, and then the response becomes faster because the impact is increased because of the flow of information. So you have the echo chambers and the restructure of society. And because it is happening a lot faster, nobody can predict. So before we could regulate the system because there was enough time, but now it's getting faster and faster because of the momentum of the flow of information through electricity in the computers that's scaling up exponential tech and innovation. And that's the problem. Because if we keep going like this, we're gonna build a bunch of tools we can control, and then we're all gonna pretty much destroy ourselves. Because everybody's gonna have access to a virus that can kill everyone. So either that, or it's gonna become only a few group of people have all the control, which means that eventually everybody dies as well. Because if you have that cycle, it's gonna become a vicious cycle, and the small group is gonna collapse. Because that's what happens. Yeah, I can understand that. It's hard. Yeah. I think what's happening is that's what I think, at least right now. Like, I don't think we have a choice between, we have to build the systems, because otherwise I think the path is clear. And the direction we're going is the social credit score stuff, and data becomes, the transparency is inevitable, and everything gets controlled by the system, because yeah, that's the natural direction. But there must be a middle way, and I think that what's happening right now is that the limbic system of the human mind is overfitting the data of the universe, if that makes sense. Because we have a hardware that doesn't adapt as fast as our innovation is capable of transforming reality. So our system is lacks synchronicity with the environment because the information we are receiving, the incentives we have, is basically determined by the limbic system, which is living in thousands of years ago. So there's this delay. So the limbic system is not an efficient neural network to create a scalable system in exponential attack. And the more powerful the innovation becomes and the technology becomes, the bigger the effect of that mismatch between what the limbic system thinks is good and what reality actually is. And that's the problem with the economy, because economy is just the consumer is the consumer is the limbic system of the collective consciousness. So everything is connected in that sense, because what AIs are doing are just feeding data points, trying to approximate functions in order to predict behavior, which is what the human mind does as well. And the brain is a computer in that sense because it has electrochemical impulses that are configured and transform themselves into higher order abstractions that becomes that evolves in the abstraction space, which is kind of the internet, because everything we build is an exemplification of ourselves, because everything works in a fractal way. If you actually want to get a machine to learn something, I suggest using something like TensorFlow, because you will get more raw number crunching going than by trying to do it yourself. Number crunching is the limiting factor. Yeah, my biggest concern with that, but I think it's inevitable, like the biggest issue I have is that the more you build stuff on these frameworks and platforms, the more dependent you become on them. And that's the problem I have, because I'm not sure if when I'm using Google's API, I'm gonna be dependent on their API if I build my whole system with them. And then if the long term, if I'm trying to build something that is new, there's gonna be resistance. And if it's built on top of the framework, it's likely gonna fail because it's part of the system itself. But I'm not sure if that's just too big or kind of naive concern, because I should probably be using Google TensorFlow and whatever, because we actually don't have any time anyway, because they're saying 8 years we're gonna have something that's more intelligent than all humans combined. So it's pretty much pointless anyway. But yeah, basically Python itself is much slower than something like C++, but libraries like TensorFlow don't actually do the number crunching in Python. Whether they run it using efficient low-level numerical kernels, wise people spent a bunch of time optimizing. Technoterm is not invented here. Yeah, but I think that I think it's worth it to learn C++ because of understanding, not necessarily the application itself. To increase the level of understanding, so I increase my chances of building the system, a better system. But even if I use C++, I'm probably gonna use the TensorFlow low-level API to build the networks, which is probably gonna take a lot of time as well because it looks incredibly hard to do it. The practice of rejecting any code not invented here. Oh, okay. It's a matter of balance. Yeah. Everything in life, right? It's a matter of balance. And that's the problem. More power, the more difficult the balance becomes. But I think it's probably just a waste of time to concern ourselves too much with this stuff because it's probably gonna happen anyway. But I think it's better to at least um, try while it doesn't happen than to just sit here and wait for it to happen and just try to make money, which I obviously am trying to do as well. But yeah, there's another balance because making money is actually advancing the process of reinforcing the systems that are out of balance, which are probably going to lead to some catastrophic event in the future or some singularity that nobody can predict what's going to happen, which in my case is, in my opinion, is the best option because I'm not so concerned with a very intelligent being. I'm more concerned about a not very intelligent being in control of the very intelligent being, which is the way more dangerous part. The problem is not the eye itself; is like we are a bunch of monkeys, and then if you give the power of God to a monkey, it's probably gonna do some dumb shit with it. Dependencies, yeah. I think it's just the way that my mind rationalizes not working on the stuff, which is why the reason why I wasn't sure about the compiler if it's good or not to learn it because that's how our minds work, right? We are us rationalizing stuff, so we avoid the more challenging things. But I think the best way is probably learn C++ and then use the APIs and whatever. It's gonna be whatever it's gonna be. And they already have all the control as well because Microsoft owns everything pretty much. And if you don't want to use Microsoft, then you have to use Linux, and then everything's already harder because there might be a lot of other applications that don't accept Linux or other problems, and then it just goes on forever. Writing actual production level compilers is one of the harder types of programming could, yeah. So might be better just to start with the artificial intelligence after I learned C++. And I probably definitely expect that I will fail a lot to make it happen. Because everything works like that. You always fail a bunch and then until you get good. Yeah. Automation, thinking, other jobs, and cryptocurrencies gaining popularity. Governments will be forced for to implement, but that's not the issue. That's not the only problem, right? That I would say that's not even the biggest problem. The biggest problem we have is distribution of power. Like, how do you maintain the exponential power? Because think about it. Yeah, it's kind of depressing to think about all this stuff that can go wrong. But hopefully, I think it's gonna be fine. Yeah, either way, it's gonna be fine. Exactly. If you do have any ideas on what kind of systems we can build that are going to increase our chances, I would appreciate learning about them. Well, I think we can't think about a scarcity mindset because is everyone on the same boat? Like, if your system relies on other people not knowing about it, then it's already a very bad system. Yeah, exactly. Markets economies are inefficient. That's the problem. To me, that's the biggest problem. And then it creates this reinforcing loop because everybody depends on money. So the system protects against innovation. Like Google buys everything, and then um, we need new incentives, I think. And I think it has to be possible to build it because there wouldn't be a middle way. There wouldn't be separation if there wasn't a middle way. Make more money with money, then you can buy producing or supplying actually goods or services. What we've seen from cryptocurrency so far, those are even more broken than traditional money, and precisely in the same way. Because they're not creating a new paradigm, they're just reinforcing the paradigm in a different way through computation. But the issue is the relationship between, I think at least, the relationship between human beings, the politics, and the technology. So I think the problem is that it's an asymmetrical feedback loop system where you have electromagnetic impulses creating abstraction. The abstraction scales exponentially. The electromagnetic impulses scale linearly. So the limbic system gets fitted to the electromagnetic impulses. Then the innovation happens and it grows out of bound from the limbic system. And there's no correction because the correction itself is corrupted by the limbic system, which means that the consumers dictate everything and the consumers are pretty dumb. Not because they are specific people that are dumb, but because that's the function of social structures at a macro level. It's just a bunch of probabilistic because the sum makes the genetic mutations that create the personality profiles that evolve over time based on the systems we have, which is basically the market's economy abstraction to pass the responsibility for who's going to deserve what and property as well. And that becomes a exponential distribution because that's how it works on social structures is 80-20 rule from Pareto. And that becomes an oscillator from the probabilistic profiles to the is either normal or logarithmic that determines the genetic components of people, genetic mutation, I think, that becomes exponential with markets and that oscillates at some frequency depending on the environment, which is the overall electromagnetic uh, structure of the universe. And that frequency is asymmetrical by nature, which might be the way that this universe works overall because we haven't seen aliens yet, which might means, according to the Fermi paradox, that we it's a cap for the power amount of power you can have in this universe, given the law of gravity. More and more money, so serves no purpose other than being a token speculative markets. Yeah, let me think about that. But I don't think that's the only issue. Because even if you didn't have money, even if you don't had the ability didn't have the ability to create money out of nowhere, there would still be a misalignment of incentives in what we build. Because think about this, what happens if everyone has the ability to create a nuclear weapon in their house? It's just a matter of probabilities. The more likely it is for someone to be able to destroy the whole thing, the bigger the chances that that's gonna happen. So you need a cap on the distribution of power. Otherwise, there's no. It's not just about the creation of money. It's about the misalignment in incentives and the distribution of the overall structure. Because power is the amount of influence you have in their environment. So it's like you're amplifying the amount of influence that specific portions of space-time has on the overall structure. And the bigger that energy becomes, the harder it becomes for the structure itself to maintain itself. It's kind of like the sun, I think. The difference between the sun and the earth is like the instability of the molecules inside the thing. And then you have self-destruction because you can't contain it. So I think what we need is a different way to is the market itself, not just money, the market structure. This is how we determine who has the right to do what. Not only that, but on the space itself, the land, the house. Like why some people have big houses, some people have small houses. If you don't have a way to justify that, then it becomes the problem of science and the epistemology of science. And that's the problem because even though we can understand that the science has limitations because it's basically pretty much built up on top of the assumptions that I forgot what I was gonna say. Some other stuff came into my mind. I remember a time when countries actually thought they'd pay off their national debt, but it is clear now the game is to grow your debt. It's lower than all the other countries, but they all seem to be reaching for infinity. Yeah, the function of money is slavery, right? Like nothing really changed. But everyone is a slave in some way because you have entropy. The universe, the entropy always increases, so everybody has to do things. And because everybody's designed to survive, nobody wants to do anything. So the limbic system is constantly making us rationalize why you shouldn't do things and why other people should do things. And then you have ideas that justify that, and you lie to yourself, and everyone else does the same. So we can't just be trapped by opinions and subjectivity, right? because then otherwise it becomes the problem of who is more convincing, which is aristocracy. But then we think we solve that by making facts, but facts are illusion because they're just a consequence of experimentation, and they can be corrupted the same way that the opinions can by money, which is markets. So money corrupts science and the information, the flow of information, so that you have the same reinforcement cycle, but with an extra step. And the same reinforcement cycle is the problem because if you can use the paradigm of logic and experimentation to determine what's correct or not, who's going to decide who can do what and who has access to what? And that's one problem. The other problem is I think that's the main problem because the access of data is just an extension of this problem. Like, why is Elon Musk going to decide who gets to drive or get the next beta test? Or why is he the one that decides that? It's just because he built the company. And then the more, let's say that because the tendency of technology is just one is going to, not technology, but the markets, one company is going to dominate everything. So let's say it's Tesla. Let's say you only have self-driving cars in the world, and Tesla owns them all. Who gets to decide who gets to drive or not? That's the point. Yeah, sure, man. I know politics is a difficult issue, but I'm gonna talk about it here regardless because of the goal I have. Which I think is important enough. Oh, it's actually very dangerous as well, but and really important. So yeah, I think I'm gonna be done for today. I'll come back another time. And I'm probably gonna study stuff uh, offline on this Django, Flask, and other things. And then when I come back, I'm gonna continue this course on C++. See ya.